everyone, we're going to find the sum of the series given here. The first thing I'm going to do is rewrite this. So I'm just taking the same thing and rewriting it to see a pattern. So if I look at the first term, I can write this as 1 times n, and then plus 2 times, see what I'm doing? I'm just rewriting it basically, plus 3 times n minus 2 plus 4 times n minus 3 plus dot 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 plus n plus times 1. All right, now that we have that, let's look at our sequence. If we just look at the terms, we have 1 times n. The next one is 2 times n minus 1. Next term is 3 times n minus 2. The next term is 4 times n minus 3. And then we would have the last term is n times 1. So looking at this, this would be your first term, your second term, your third term, your fourth term, and then your nth term. So basically, if we look at a sub k, so a sub k, and look for the formula, and let's look at this one and maybe this one. Basically, these numbers match, right? So our formula would be k times n minus, now if you match these numbers up and this is k, this would be k minus 1, right? Because if this is going to be your k and you match it up, so 3 minus 1 is 2, 4 minus 1 is 3. So this is what our a sub k is. Now I can rewrite this as equal to k times n minus k plus 1. All right. Now, that means we're going to write this the sum of k equals L, or anything, you could do anything, to n of k times n minus k plus 1. Now, I'm going to go up here and distribute this out. This would be kn minus k squared plus k. So what I want to do is group these two together, kn plus k, and then minus k squared. So I'm going to break up my sum, and this is going to be the sum from k equals L to n, and this I can rewrite as k times n plus 1, and then minus the sum of k equals L to n of k squared. So this is what we're going to use to get the sum. And I'm going to write it down again. So we have, let me write it here. Let's see, we have, well, I'm going to rewrite it. We had before the sum k equals L to n of k times n plus 1. That was our first one. So I'm going to pull this in front because we're dealing with k. So I'm going to write this as n plus 1 times the sum from k equals L to n of k. And the last one was just k squared, so that's going to be the sum from k equals L to n of k squared. All right, so basically what we have here, just copy down your n plus 1, and then just for k, that is this formula here. So you're just going to write times n times n plus 1 divided by 2. Then we have minus, and now we're using this formula here. So that's going to be minus n times n plus 1 times 2n plus 1, all divided by 6. Now what I'm going to do is factor out this n plus 1 divided by 6. All right, that means I need a 6 here for the common denominator. So that means I have to multiply this by 3. So I'm going to multiply the numerator by 3 as well. So if I factor that out, I'm going to get n times n plus 1 divided by 6. Now, what's left is going to be 3 times n plus 1 minus this part, 2n plus 1. All right, now let's simplify this part, and that's going to give us n times n plus 1 divided by 6 times n plus 2. So your final answer is you just multiply, this is over 1. So we can write this as n times n plus 1 times n plus 2, all divided by 6. That's your final sum. Thank you. Have a nice day. Bye-bye.